Welcome friends to this first week of lectures for this NPTEL course of Environmental Soil Chemistry. I myself Dr. Somshubra Chakraborty, and let us start the lecture 1. Basically in this week we will be basically covering these topics or concepts. First of all, we will be talking about what is soil chemistry and environmental soil chemistry, and then we will be talking about a brief about the evolution of soil chemistry, and then we will be talking about modern environmental movements, contaminants in water and soils, and then we will be talking about soil contamination, and also we will be covering the molecular and environmental soil chemistry. So, the question first comes that what is soil chemistry and environmental soil chemistry, and what is the difference? So, soil chemistry is a branch of soil science that deals with the different types of chemical composition, chemical properties and chemical reaction of soils. You have already know that the soil is basically composed of different types of components. There are certain components which are solid, some components are liquid and some are gaseous. Soil is basically composed of fractions which are sand, silt and clay, organic matter, soil air and moisture. And soil chemistry basically deals with the soil chemical properties. Remember, so basically that means the soil is a heterogeneous mixture of air, water, inorganic and organic solids, and also soil contains millions and millions of microorganisms. And soil chemistry has traditionally focused on the chemical reaction in soil that affects plant growth and plant nutrition. There is a specific terminology for this, we call it edaphology, when the soil chemistry is basically concerns about the plant nutrition. Now, environmental soil chemistry is the study of chemical reactions between soil and environmentally important plant nutrients, also radionuclides, metals, metalloids and organic chemicals. So, what is environmental soil chemistry? Environmental soil chemistry is fundamental in predicting the fate of contaminants in the surface and subsurface environments. We are not only concerned about the surface of the soil, but also we are considering the movement of different types of contaminants and its interaction in the soil in the subsurface zone. Now, it is necessary for understanding of environmental soil chemistry that you should comprehend an array of chemical reaction that contaminants may undergo in the soil environment, which may include equilibrium and kinetic processes such as dissolutions, precipitations, polymerization, adsorption, desorption and oxidation reactions. So, these are different types of reaction which are integrally involved in the field of environmental soil chemistry, because they impact or control the movement or interaction of different pollutants in the soil water system. These are the processes which also affects the solubility, mobility, speciation, toxicity and bioavailability of the contaminants in soil, in surface water and groundwaters. So, that is why we need to understand these processes in details before we can discuss about different types of soil contamination processes. So, what is the evolution of soil chemistry? If you consider the evolution of the soil chemistry, in the early 1850 by J. Thomas Way, is a scientist in the Royal Society of Agriculture in England. He found that soil could also absorb both cations and anions, and that these ions could be exchanged with other ions in the soil system. And so, after that several discoveries have been made, and during early 1930s, Hendricks and co-workers found that clay minerals in soils were crystalline, and X-ray studies were conducted to identify different types of clay minerals and to determine their structures. Now, you already know different types of clay minerals which are present in the soil, and you know that they can be divided into crystalline and non-crystalline. And in the crystalline, we have already discussed in our previous NPTEL course different types of crystalline clay minerals, like 1:1 type of clay mineral, 2:1 type of clay mineral, 2:2 type of clay minerals, and also amorphous clay minerals like olefin. So, we have discussed this. So, you know that crystalline clay minerals are the prevalent inorganic fraction in the soil, and these were first described by the Hendricks and co-workers in 1930, and they started the X-ray studies. And studies on soil acidity, ion exchange and retention of ions by soils and soil components such as clay minerals and hydrous oxides were major research themes for many decades. If you consider last 50 years of soil research, you will see that most of the soil chemistry based research were confined in dealing with soil acidity, ion exchange, retention of ions by soil, and different types of soil components, and also different types of clay minerals or different types of soil colloids. So, the modern movement or modern evolution in the field of soil chemistry started about 30 years ago, when the emphasis was on the reducing pollution from smokestacks and sewer pipes. Basically, remember that all these modern environmental movement happened in the developed countries like UK and also in other European countries and also in the United States. In the late 1970s, a second movement that focused on toxic compounds was initiated, and several laws have were enacted which had a profound influence on environmental policy in US. So, there are several laws which were enacted by the US environmental agencies, and these are the Clean Air Act of 1970, the Clean Water Act of 1972, the Endangered Species Act, the Superfund Law of 1980, and the amended Resource Conservation Recovery Act, that is called RCRA of 1984. So, these are the laws which were enacted during that period, which helped in the modern evolution of soil chemistry from the traditional fields like soil acidity, then colloids chemistry and other soil exchange phenomena, to the soil contaminant interaction and movement. So, the third environmental wave, which began in late 1980s, were basically done by the farmers, businessmen, homeowners and others, when they questioned some of the environmental laws containing regulations that some pollutants cannot be contained in the air, water, soil and levels greater than a few ppb. So, these movement, the third movement in this evolution of soil chemistry, basically initiated by the common people like businessmen and farmers, because they were concerned about some some laws and their and the maximum limits they have imposed for certain elements up to certain ppbs. So, they questioned why you need and what is the possible modification for those limits. So, that is how the laws become more and more stringent and also this environmental soil chemistry domain became more and more important in daily life. So, once we completed the evolution of soil chemistry, let us discuss a overview, or let us have an overview of the contaminants which are present in waters and soils. Now, there are a number of inorganic or organic contaminants that are important in water and soil. They are basically, first of all, they are basically plant nutrients, And when we talk about the plant nutrient, they are basically nitrates and phosphate because they cause the eutrophication. Also heavy metals like cadmium, chromium and lead because they can cause different types of health hazards when they are mixed with the soil and water. Different types of oxyanions like arsenite, arsenate and selenite. Arsenic is a major problem in Indian subcontinent where you will see the groundwater contamination by arsenic is creating a hazardous condition both in West Bengal state of India as well as in Bangladesh region. Different types of organic chemicals. We have already discussed in our introductory lecture about the PCBs, how PCB is polluting the environment in India. So PCB is a very important organic chemicals which is a hazardous chemical. So chemicals like PCB and PAH, all these are very much important for contaminating both water and soils. And this also different types of inorganic acids and radionuclides are also important contaminants for water and soil. Remember, the sources of these contaminants basically are fertilizers, pesticides, acidic depositions, agricultural and industrial waste materials and radioactive fallouts. So, that is why all these inputs are very much important in the context of environmental soil chemistry, and that is why there are strict rules and regulation imposed for controlling the use of these compounds for soil and water. So, let us start with the water quality. Now, there are two basic types of pollution. Once we are considering the different water pollution, there are two basic types of pollution. One is called point source pollution, another is non-point source pollution. Now, point source pollution or point pollution, another name is point pollution, is a contamination that can be traced to a particular source such as industrial site, septic tank or wastewater treatment plant. Now, it follows the definition by United States Environmental Protection Agency or US EPA that any single identifiable source of pollution from which pollutants are discharged such as pipe, ditch, ship or factory smokestack. And this was given by the scientist Hill in 1997. Remember, factories and sewage treatment plants are two common types of point sources. But as far as the water quality is concerned, you can see that the sewage treatment plants are the major source of point source pollution. So, as you can see in this picture, the sewage from the different industries are treating when they are exposed to the water bodies, they are acting as a point source pollution. These are some other pictures of point source pollution. As you can see, the large farms of different animals can also be act as a important point source pollution, because the animal waste can be discharged into the nearby water body as a point source pollution. Here you can also see the factory smokestack which also acts as a point source pollution. The other source of pollution or water quality is non-point source pollution. The other name is non-point pollution. Now, the non-point pollution results from large areas and not from any single source and includes both natural and human activities. So, what are the sources of non-point source pollution? There are several sources for non-point source pollution. First of all, the major source of non-point source pollution is agriculture. Due to the runoff which is generated as a result of rainfall, a huge amount of fertilizer can move from agricultural fields to the nearby water bodies and which creates basically the eutrophication problem. So, agriculture is considered as a major source of non-point source pollution. Human is another agent of non-point source pollution. Forestry, urban constructions and mining activities and atmospheric depositions are also important as a source of non-point source pollution. What are the naturally occurring non-point source pollutions? The naturally occurring non-point source pollutants are geologic erosions, saline seeps and breakdown of minerals and soils. So, non-point source pollution, these can be explained by these two pictures. As you can see, first picture is basically showing the runoff, the field runoff due to the rainfall, and also when these runoff from the adjacent fields ultimately reaches to the nearby water bodies, it contaminates the whole water body, and this is a very good example of non-point source pollution, and this type of pollution is prevalent in all countries. This picture also gives you a snapshot of non-point sources. You can see that these are some major non-point source pollution. For example, urban streets, suburban developments, rural homes, croplands, animal feedlots, these are very important source of non-point sources, from which all different types of contaminants, maybe it is a fertilizer or organic or inorganic chemicals, can go to the nearby water body to contaminate. However, these are some point sources like wastewater treatment plants and factory. So, this slide basically gives a snapshot of different point sources and non-point sources pollution. Again, here in this picture, the point sources are wastewater treatment plants and factory outlets into the water bodies. However, non-point sources are suburban developments, urban streets, rural homes, croplands and animal feedlots, from where the different nutrients and contaminants can move in bulk through water or rainfall and ultimately reaches the nearby water body to contaminate. This shows also another condition where there is a pollution from leaking petroleum tank. So, you can see here, when the tank is leaked, petroleum tank is leaked, it goes and ultimately contaminates the nearby water wells and other groundwater sources. Now, this slide also shows the non-point source pollution, where water in many central China's rivers are greenish black, which is due to the uncontrolled pollutions by thousands of factories. So, this is also an example of water quality deterioration when the water is getting the pollution from different point sources. Again, here the water is getting greenish black because the water is getting sewage from different industries through different point sources. In India, daily more than 1 million Hindus bathe, drink or carry out religious ceremonies in the highly polluted Ganges river, and as you can see the water contamination issues in India. It not only so different types of point source and non-point source pollution creating a huge amount of pollution in the river Ganga, and ultimately which is being used by millions and millions of devotees in India. So, the two plant nutrients of greatest concern in surface and groundwater are nitrogen and phosphorus, and their impacts on water quality also very important. Now, remember, the United States Environmental Protection Agency has established a maximum contaminant level, we call it MCL, of 10 milligram per liter nitrate as nitrogen for groundwater, whereas total phosphorus not exceeded 0.05 milligram per liter in a stream where it enters a lake or reservoir and total P in streams that do not discharge directly to lake or reservoir not exceeding 0.1 milligram per liter. So, these are different types of maximum contaminant level which are set up by United States Environmental Protection Agencies, because once these nutrients enters into the big water bodies, they create eutrophication problem. What is eutrophication problem? When the nitrogen and phosphorus enter into the nearby water bodies, it increases the fertility levels which produces the algal bloom. That means, whatever the algae which are present in the water body, they will take up that nutrient and they will multiply, they will create a bloom. And due to the excessive growth of these algae and other problematic aquatic plants, there will be a condition where the dissolved oxygen from the water will be reduced. We call this condition as hypoxia condition. So, in this hypoxia condition, all the organisms, other organisms which are present in the water body will be eliminated. So, this is the ill effect of eutrophication, and this eutrophication is mainly mediated by the excessive nitrogen and phosphatic fertilizers which we apply into the agricultural fields. So, that is why indiscriminate use of agricultural resources are creating a big problem as far as the environmental soil chemistry and also water chemistry are concerned. So, remember, excessive nitrogen again in the form of nitrates has been linked to methamoglobemia or blue baby syndrome. It is a very important disease which occurs due to the nitrogen pollution in the groundwater aquifers. Also, it results in abortion in human and increase the risk of non-Hodgkin's lymphoma. Phosphorus as phosphate is tenaciously held by soil through both electrostatic and non-electrostatic mechanisms which we will discuss, and usually does not leach in most soils. On the other hand, nitrate nitrogen is weakly held by soils and readily leached in soils. Now, again remember that major sources of N and P in the environment are inorganic fertilizers, animal manure, biosolid application, septic system and municipal sewage system. So, the discharge from these sources or application of some of these sources has to be highly regulated to control the pollution scenario which is due to the nitrogen and phosphatic fertilizer. So, what is the current status of this nitrogen and phosphorus fertilizer consumption in both US as well as in India? So, let us consider first US condition. Now, inorganic nitrogen and phosphorus fertilizer increased 20 and 4-fold respectively between 1945 and the early 1980s, and after that they leveled off. In 1993, around 12 million metric tons of nitrogen and 2 million metric tons of phosphate was used nationwide in US, and at the same time animal manure accounted for around 7 million metric tons of nitrogen, about 2 million metric tons of phosphorus, and additionally about 3 million metric tons of nitrogen per year were derived from atmospheric sources. So, if you can see this plot, it basically shows the changes in nitrogen and fertilizer use over the decades. So, you can see from 1945 to 1995, there has been continuous increase in nitrogen fertilizer consumption or sales in million tons per year, and also there has been an increase of phosphate fertilizer sales. However, comparatively the fertilizer sales in case of nitrogen is way higher than that of phosphorus, and this is from a US Geological Survey circular which was published in 1999. And you can see this table has been compiled from a research, and it has been found that they are basically showing the natural concentration of various elements, ions and compounds in groundwater. So, you can see for different elements starting from calcium to barium and beryllium, and you can see different types of typical values and their extreme values, and also you can see the elements up to zirconium and what are their extreme values. So, that will give us the idea about the safe level of these elements in the groundwater and what is the maximum threshold level we cannot violate, and these should be keep in mind while we are devising different types of management practices. What is the fertilizer consumption situation in India? If you consider the fertilizer consumption situation in India, United States and China, you can see in all these three countries there has been a continuous increase in fertilizer consumption in million tons starting from 1960. In India, starting from 1960, there has been a as a result of green revolution, there has been a continuous increase in fertilizer consumption. In China, the increase is more steeper, and that shows that all these sources of groundwater and soil pollutions are are very important, and also that shows the alarming situation where these developing countries like China and India are continuously increasing the use of these inorganic fertilizers, and which can create a very hazardous situation in the near future. And this slide also shows a snapshot of different types of interactions which are going through different point sources and non-point sources. You can see that runoff can be generated from the nearby areas, and also wastewater can be dumped into the nearby water bodies. Runoff can be generated from the agricultural fields, which will ultimately contaminate the nearby water bodies, groundwater, and also this groundwater will be discharged into the streams, and ultimately creating the pollution, creating the pollution of the total soil and water system. This slide is self-explanatory. I would request you to go through and see the details, and this is from the US Geological Survey report of 1999. So, that is how we completed today the evolution of soil chemistry, and we also discuss about the point source pollution and different non-point source pollution and how they interact in this soil and water system. In the next lecture, we will be discussing the other aspects of soil pollution, and we will be discussing about the pesticides and other sources of soil contamination. Thank you very much. Let us meet in the next lecture.